So we can see in the C++ script, we got the main function, we've got our variables here, which I'll explain everything. We've got the Windows SOC API starting up and initializing the connection. We are creating the socket. We are setting up the target address that the host would connect to, which is our target machine, so that when the person runs client.c++, this file, when they run this file, it will send out a request, it would start a connection. We can have a listener running on our Kali Linux machine that when we run this script, this program will read this variables here to connect to this address, which is the attacker's address and port number, which it's listening on. Then we connect to that socket and we maintain a stable connection. Then we use the command.exe program to spawn and create that process for us to interact with the client's machine, which is the victim. So to see what this looks like, I've got my Kali Linux machine here. I'm going to go ahead and run netcat. As you can see here, I'm running netcat, and if I go ahead on my victim's machine, which is by the way on Windows, if I go ahead and run it, you will see this connection happen. So when I click this button, when I run this testware, it's not even malware, it's just testing a connection, creating a connection for us to connect to the victim's machine, which is my Windows machine. So my main machine is Windows. The Kali Linux machine you see here is the hacker's machine, and we are just waiting for a connection. They have the file, so we're just waiting for them to open the file. Now, what malicious actors would do is that they would trick the victim into actually opening that file so that they actually have a connection to that person's machine, right, or computer. So if I go ahead and click this button, I'm just going to move it here so you can see both, so that I'm not capping. So you can see here, if I run this program, watch the right side. If I click this button and run it, it's going to compile the code and run it on the target's machine. There we go. Now, what was really funny there, I don't know if you saw that, but I actually received a Bitdefender threat detection, but for some reason it managed to still work. That's actually really cool. So it still worked, even though Bitdefender was like having a episode there. We have access to my machine because of the reverse shell that I made, which is absolutely brilliant. See, look, we are on the machine, literally. So I'm in the folder, I'm in testware, which is what the project is called. There's my C++ script. Now, if someone opens that program, or, okay, you see that? It says threat detected. I don't know if you see that behind me. I'll move. It says threat detected. It says Bitdefender has moved detected threat, and it's in quarantine. But what's really interesting, I still have access. It hasn't closed the connection is still stable, but hackers can find many other ways to prevent this from happening. They can put it into a PDF document or something else, so that when the person opens it, spawns it in the background, or they do a thing called namespacing, you know, not calling it testware, because anything with ware, it's thinking of malware, or process injection. They can like try and embed it into an existing process to try and hide it, something like that. But we can still see we are on the target's machine. This is not even like, yeah, I mean, look, you can browse around on the victim's machine. So that is the quick demo of what the C++ script does. So I'm going to walk you through it. So I'm going to go ahead and close Kali Linux now because we're done with that. So I'm using these libraries, the WinSock libraries. I'm using Windows Socket Library version 2, which is the networking library for Windows API. It allows you to initialize the socket, set it up, start a TCP connection, three-way handshake, connecting back to a client or a server. So that's everything networking related. I'm using the Windows API header for creating and spawning the process like cmd.exe. And then for the program, I've got my integer main function with these variables here, basically initializing it, setting up the socket address, the startup information, the process information that we gather. You can see here, this is me initializing the connection. So this is initializing the connection. This is setting up the socket target address here, connecting to the socket address, which is here, this here, which is being passed in. Then this is the program which we spawn. So once the person opens the program will go ahead and spawn this application, create a process, and then wait for a little bit. And then it spawns that connection which we can connect back to. And if the connection closes, it closes the socket, the threads close.